video tutorial presents a generic experimental procedure. Please consult your class notes for term-specific instructions. The lab setup for this experiment consists of a DC power supply and a custom CAM fixture connected to the Data Acquisition System, or DAC. The CAM fixture consists of a brushed DC motor with an encoder to measure CAM speed and position. The motor rotates a flywheel with an interchangeable cam. A spring-loaded cam follower contacts the cam with a roller bearing and pivots about a parallel shaft containing a secondary flywheel. The cam follower dynamics may be measured using either an accelerometer or an RVDT for rotary position, the latter being the default. Turn on the DC power supply using the front switch. On your desktop, open the X95 shortcut folder and select CAM Dynamics Main. LabVIEW will take a few minutes to open up. Once the program opens, start LabVIEW by clicking the white arrow in the menu bar. Then navigate to the Configuration tab. Verify the desired mode for tracking the cam follower is selected using the appropriate radio button. For this example, the RVDT will be utilized. Before running any test, the RVDT must be calibrated. Click the blue Auto Calibrate button. The cam will slowly rotate over the full range of motion and automatically set the gain and offset. A separate procedure will be required for the accelerometer, which is presented later in this tutorial. When finished, select the System Response tab to return to the main panel. To run a test, set the voltage as desired, in this case 5 volts. Click the green Take Data button to initiate a test. The default test will run for about 3 seconds and then ramp down for 2 seconds. When the test concludes, the measured parameters will be plotted. Click the Save Data button to save the data to a tab-delimited text file on your desktop. Here's a sample view of the data file presented in Excel. Key settings are displayed in the header. All the time-dependent variables are listed in columns, which may be imported into Excel or MATLAB for analysis. Depending on your instructor, you may wish to view the various time derivatives of displacement. The SVAJ tab is an acronym for displacement, denoted as S, velocity, acceleration, and jerk, which are the first, second, and third derivatives of displacement, respectively. These plots display an overlay of each rotation of the cam from 0 to 360 degrees. At 5 volts, the plots indicate that the cam follower nicely tracks the rotating cam. At a certain speed, the cam follower will begin to float as the cam contact force is less than or equal to 0. As an extreme demonstration of float, set the motor voltage to 12 volts and repeat the test. The first thing you'll notice is the knocking sound, which is the cam follower smacking against the cam surface. Slowing down the video, the cam follower can be observed to lose contact with the cam and momentarily float before slamming back against the cam surface. Examine the SVAJ plots and notice the difference. Iteratively adjust the motor voltage to determine the threshold speed at which float occurs. How does this compare to your math model? A compound pendulum is another method to experimentally determine the moment of inertia of the lever arm. A test fixture is available with the lever arm assembly freely pivoting on precision bearings to mitigate friction. Initiate a subtle oscillation of the lever arm by laterally nudging the assembly. Use a stopwatch to time out 60 to 100 full cycles and calculate the period of oscillation, or seconds per cycle. Use the measured period and assembly mass to calculate the moment of inertia. The spring constant, denoted K, can be experimentally determined by measuring the rate of deflection to a varying load. Use the provided fixture to incrementally hang weights from the spring and measure the ensuing deflection. Fit a line to the plotted data to calculate the spring constant. A surrogate flywheel and lever arm are provided to measure the mass and applicable dimensions. To change the cam, loosen the center screw with the provided Allen wrench and gently ease the cam off the dowel pins. Orient the holes of the new cam with the dowel pins and slide forward against the hub. Then reinstall the 1/4-20 screw and gently snug it. Don't over-tighten. Please be sure to save your data before you leave the lab today.